Science fairs with the kids.
Yeah. This is Hawaii, the state of energy, and you knew that because it's Wednesday afternoon, 4 o'clock, and every Wednesday, like clockwork at 4 o'clock, we have Hawaii, the state of energy. As a matter of fact, we have Hawaii, the state of energy all the time. Hawaii is the state of energy. And today with Louis Vega and Patrick Cross from HNEI, the Hawaii Natural Energy Institute. They're both project managers and energy specialists and research people, and I don't know where it ends. We're going to find out more about what they do. We're going to talk about waves of energy at HNEI today with those two guys. Welcome to the show, you guys.
Thank you.
Thank you.
Yeah. Why are you here? Yeah.
Why are we here? You go first.
Well, I'm here because you invited me to be here.
Okay, that's a very good reason. We couldn't argue with that.
We're here to talk about the work that we're doing in marine energy, ocean energy, specifically looking at the ocean thermal resource to be used for OTEC. Most people know what OTEC is, I guess. And then also we're looking into wave energy as a potential resources for our state.
Okay. Patrick, what would you add to that? Or if you wish to rebut it, you may.
No, I won't rebut. So far, so good. I'm actually fairly new at HNEI. I have a background as a naval oceanographer. And
You have a naval look about you. I mean that as a compliment, yeah.
I hope that's a good thing, yes.
Submariner.
Oh, even
Yeah.
better.
Yeah.
Submariners get along with everybody.
They have to. So no way out.
Okay, but enough of this frivolity. We're gonna talk to Kate now, if we may, because this is the part of our program which we deal with every Wednesday, where we talk to Hawaii Energy, and we call it the negawatt moment because it's that special time we talk about not having to produce electricity. If you don't use it, you don't need it, and this is like an alternative way to satisfy our needs for energy, right? Kate Aurelio.
Yes, that's right, Jay.
Welcome to the show. Is that microphone on?
I think it is.
Okay, I hear you.
Good.
All right, tell us what you came with. Tell us the bright ideas you guys concocted at 3 in the morning for us to save energy this week.
Well, as you may know, Hawaii Energy is the ratepayer-funded conservation and energy efficiency program that serves the islands of Oahu, Molokai, Lanai, Maui, and the Big Island. And I am an energy engineer with Hawaii Energy. We often talk about residential programs, but we also offer incentives and rebates to our commercial and industrial customers. So I've come to talk about a few of the examples of energy efficiency projects we've done with industrial customers and ratepayers around the state of Hawaii.
Okay, how about some examples then?
Sure. Well, the first example that comes to mind was at a water bottling company on Oahu. There's actually several water bottling companies, but this particular company installed a new bottle blowing piece of equipment because they actually not only bottle the water, they actually make the bottles. And they installed a new piece of equipment that saved a lot of energy. It actually recycled the compressed air, whereas the previous piece of equipment had been just releasing excess compressed air. And so by recycling it, they were able to reduce their energy consumption quite a bit. That was one project we did, and they received an incentive from Hawaii Energy and from all the ratepayers of about $91,000.
Oh.
Yes.
This was a gizmo that would catch the compressed air after it made one bottle and hold it and use it for the next bottle.
Yes, that's exactly right.
Wow.
Yep.
So is that a patented item? Because if it is, we could export that idea to somewhere else, no?
Unfortunately, I think we had to import the idea from Italy.
Well, we keep trying. Italians are very clever.
Yeah, it was an expensive machine, but I think our rebate was able to help them out with that capital investment.
Good. Okay, what else?
Another example would be a refrigerated warehouse, also on Oahu. Their energy costs, as you might imagine, are through the roof because they're refrigerating ice cream and milk and everything that comes from the mainland. And it's a huge warehouse, and they have to keep everything at or below freezing temperatures. And every time a person walks through a doorway, that is releasing the cold air into the atmosphere. And so they installed some new doors, which were automatic doors, and they open and close faster than their previous doors. It cut the time to open and close the door in half, roughly. And so they saved energy, and we were able to cut them a check for $18,000.
Wow. Did these doors come from Italy also?
No, I don't know where those doors came from. Maybe the North Pole. I don't know.
They'd be helpful there too. This is great stuff. Did you help them do this? Or did what was the sort of engagement? Did you go down to their place and say, you need faster doors? Or did they come to you and say, we want to put in faster doors? Will you incentivize us to do that?
Usually the latter. They're the experts in their field, and they typically know what new technology is out there, whereas we're still learning about some of these new technologies. So we'll go down, they'll come to us with an idea that they have for a project, and maybe they're trying to secure some additional funding to make the project more attractive. But we'll go down there and check it out and learn about it, and then we can also, once we learn about it, then we can share that with other customers that we are familiar with.
And they will too.
Mm-hmm.
You can invite them on the show, Kate.
All right.
We'd like to
I'll
talk
let
to them
them
about
know.
their doors and their compressed air thing, and and explore with them exactly how it worked and how they work with you, and the net benefits to them, to the ratepayers, to the state, and to the Italians, such as it is.
I'll extend the invitation.
Okay, is that it?
That's it.
Okay, would you please tell Ray Starling you did a great job? Why do I feel he already knows this?
I feel like he's watching me over my shoulder.
That's the way it is in Hawaii Energy. You'll always feel that. In charge people. And Rob de Veriturda, does he know about it too?
Yeah, Kate told me about it.
Okay, all right. We're all together on the same page. Thank you, Kate Aurelio. Come back soon, will you? I want to know more.
Mahalo.
Aloha. Okay, gentlemen, it's just us now. We're waiting for this moment. Let's begin by finding out exactly who you are. Luis Vega, who are you?
You have like 3 hours? No. Well, as you know, I work at HNEI in typical fashion, I guess, an academic institution, so a little bit of the academic background. I have degrees in applied math and aerospace engineering, also in oceanography. And I've been working for many, many years in ocean thermal energy conversion, and for the last 4 years in wave energy also.
Okay, major, and it's very important that we address these problems. It's not mainstream, may I say?
Oh, yes, yes.
You look around and everything is all about PV. To a certain extent, it's about wind. To a certain extent, it's about geothermal. That's it. I just exhausted my list. Did I miss something?
No, you.
That's what the big ones are, and we should never forget ocean energy because there's so much of it, and the same thing with OTEC.
Well, we can of course talk eventually about the challenges why we're not.
I want to do that. Yeah. Okay, and Patrick Cross, tell us about life in the submarine and how you got from there to here.
I can't tell you about the submarine, or I'd have to kill you.
It was probably nuclear. I notice you're glowing a little. Never mind.
No, as I said, I have Navy oceanography background, and a couple of degrees along the way in oceanography, meteorology, and that sort of thing. And came aboard HNEI relatively recently, several months back. Due in part to the fact that we have this opportunity to bring in some additional funding particularly in the wave energy area. So I'm coming aboard to kind of help manage that program and push it forward.
Who's funding the efforts of HNEI? I mean, it's really important what you guys do, and I just like the world to know who's helping you do it.
Well, the broader efforts of HNEI is a number of funding sources, specifically in the ocean energy arena. It's the Department of Energy, and
Federal.
it's the U.S. Navy.
Oh, good.
Yeah.
All right.
And as much as they can, although a little bit the state of Hawaii also, but
Yeah.
they don't have the kind of funding that the feds have, basically.
So, let's also capture the fact that HNEI is part of the university, right?
Oh, definitely, yes.
So, where's your office anyway?
Post building?
On campus?
Oh, yes,
Yeah.
yes.
But you also have this research building behind Hawaiian Electric.
Yes, yes, that's where we keep the affordable,
The fuel
fuel
cells.
cells,
yeah.
almost photovoltaic fuel cells, yes.
That's quite a remarkable building. It's a building within a building, and it's a shell kind of.
Yes,
I
yes,
had a tour of that.
because you need to keep it pressurized, so if there were to be a problem, I shouldn't talk about it.
Hydrogen, after all. So let's get down to exactly what the work is. Let's see. Why don't we begin with you, Luis? This is based on looks or age. I'm not sure.
So let's first begin with, in general terms, with the fact, well known, that our state is really blessed with a resource. In the case of wave energy, we know exactly, we can mathematically determine how much energy the waves contain, but the challenge there is to convert that energy into a useful form. And we're still, we meaning all of us at large, not just us, but the community at large, including people on the continental USA and people in Europe, and also in Korea, Japan, trying to design and test and develop the equipment that will convert that energy into a useful form to us, meaning electricity to begin with. In the case of ocean thermal energy that we have known in Hawaii for many years now, it's an ample resource that also has been, we have already demonstrated how to convert that resource into a useful form. That has been done here in Hawaii with small experimental plants. But we also determined that we needed to get to a larger size to be able to go commercial. And that has been the challenge for almost 20 years now, almost 30 actually. How do you get funding to proceed beyond experimental plants?
Because you need lots of funding.
Yeah, one thing I like to add to that, if I might, is that you mentioned before wind energy, and I'm also all for wind energy, but I like to ask people, why do you think that wind energy is commercial now? And the answer is real simple, because the Danes and the Germans put a lot of money into it, and they developed the technology, and now we're benefiting from it. We and along many other countries in the world. So likewise with wave energy and ocean thermal energy, we meaning our governments need to, like it's being done with wave energy, we need to step up and provide the funding to develop the, in other words, the resource is there, we know that. Now, how well can we use that resource? To do that, we need to have funding to be able to test the equipment.
Sure, because I mean, it's new technology, it's high technology, and we don't naturally have it available. We have to invent it, and this kind of technology requires a lot of money, and you wouldn't want to deploy it unless you had worked out all the bugs and all.
Right.
So, which one do you want to talk about first? OTEC or wind technology?
Because
I'm sorry, wave
Patrick
technology.
is working wave energy. We work together with wave energy, but Patrick's not working with ocean thermal. So if you want me to talk about ocean thermal, you want me to tell you in general terms where we are at, or?
I think we should flip a coin.
Okay, it's up to you.
Yeah.
Like in soccer, like in football.
Okay. Heads is ocean thermal.
Okay.
Tails is wave energy. Okay, ready?
Yeah.
Heads.
Ocean thermal.
Ocean thermal.
Okay.
Okay.
As you probably know, this is, I like to call it the third rebirth of birth or reincarnation of OTEC, because what we call OTEC for ocean thermal energy conversion, it got started really over 100 years ago, was proposed in France, without going into details about it, and it was successfully tested here in Hawaii in 1979, 1980, and then by the Japanese in the island of Nauru in 1981. Then we did some experiments here in Hawaii. And it got to a point that we know exactly how to convert the resource, the thermal resource, into electricity. We've done that, we demonstrated that. But the issue that we have now is how do you do it in a large enough scale such that you can be cost effective? And cost effectiveness depends on who's deciding what cost effectiveness is.
Material science fit in here anywhere?
Oh, definitely, because for example, we use something that's called heat exchangers, without going into detail, that represent between 1/4 and 1/3 of the total cost of the plant. And the best material that we have now is titanium. But titanium is highly expensive, relatively speaking. So we've been experimenting since the 80s really with the possibility of using aluminum that's much cheaper.
But it's not as good.
No, it's just as good. It's just that we determined in the 80s how well and what kinds of aluminum alloys to use such that they can work fine in seawater. But we determined that with coupons or plates. But then when you put it together, you will have bends and ducts, and we have to determine what happens with that.
So let me try to sort of recap on that, because I think you're talking about the core points here. So the seawater is corrosive. You have to have an exchanger to make it work as a matter of the scientific process. The exchanger has to be in a metal. The exchanger can't, get corroded or it won't work. Titanium we know works,
Yes.
but it's very expensive. Aluminum, we're still finding the best alloy of aluminum that would match titanium, and that would be good because that's not as expensive as the titanium.
Exactly, yes, exactly.
So where's the research going? I remember going out to Nelha,
Right.
and they had actually a shop there where they had some graduate students, researchers, I guess, maybe HNEI people, working on exactly what kind of alloys were the best.
Are you talking about 20 years ago or now?
2-3 years ago.
Okay, so then you're talking about Mackay Ocean Engineering. They are-
That's right.
Yes, yes.
Yes.
What they have set up a test loop basically to test different aluminum alloys, and the beauty is that a lot of that work was done in the mid '80s by Argonne National Labs at the same facility. But before we had this sophisticated equipment that allows us to do testing with by using lasers, for example, such that you can determine the amount of corrosion taking place without having to remove the coupons. We call it coupons, pieces of aluminum from the actual water. So we can run tests much longer than
All
before.
about testing. Yeah.
Yes, and they're doing really some wonderful work there. Like I said, first, we already know that some alloys will work fine in flowing seawater. We know that for a fact, but then you have to now take those coupons and build them into a structure that will have corners, bends, ducts, and that is a component that we need to find out more about it. What happens when you weld it together? What happens when you put a tube in there? We need to find those things out, and that's what we're doing right now, working with Mackay. They're doing the research.
I just had an idea I want to share with you.
Go ahead.
Yeah.
Go ahead.
So SOEST,
Right, that's what we
Okay.
work. We're part of SOES.
you're part of SOEST,
Yeah.
okay. It has all these scientists who are working on the ocean. I mean, most recently we went out to see Dave Carl's, what do you call it?
Seymour.
Yeah,
Seymour.
Yeah.
Yeah, Seymour last Friday. It was fantastic.
Oh yeah, he's doing amazing work in there.
Yeah.
Really.
So part of it is chemistry. I mean, part of it is microbiology.
Right.
What do you call it? Macrobial oceanography.
yeah.
But part of it is chemistry, and I wonder if you guys are collaborating, or you could collaborate, in order to determine how the component elements of the ocean, would work in the corrosion, and how to,
I think that that was done in the 80s, working with UH. But I think we're perhaps beyond that. We're to the point where we need to work with industry, because one big issue, one thing that we learned in the 80s was that 80s and 90s was that something we like to call constructability. Can you construct this device using existing equipment? And that's what Mackay is helping us do by being able to really experiment with the kinds of components that will be part of a real system.
yeah.
But we're beyond the chemistry issues at this point, really. It's more getting enough hours of testing with seawater flowing next to the aluminum
Get the
coupon.
exact right alloy.
Right.
And, okay, and we're going to take a short break. When we come back, I'd like to know what happens if you do get the exact right alloy. What follows that? What does that mean in terms of the deployment of OTEC to the world? And that's pretty sexy. I know it is. Okay, that's Louis Vega, and Patrick Cross, both from HNEI, here on Hawaii, the State of Clean Energy. And we're talking about waves of energy at HNEI. I'm Jay Fidell. We'll be right back.
I'm Hong Jiang, host for Asia in Review on Tuesdays.
And I'm David Day, host for Asian Review on Thursdays. Both of us broadcast our respective shows at 4 p.m.
And my topics tend to deal with questions related to environment, culture, history, and sometimes human rights.
And my shows tend to be on international business, foreign policy, geopolitics, and national security. And you can watch our shows live on the ThinkTech website at thinktechhawaii.com.
And you can also watch us on YouTube or Olalo.
So come join us on Thursdays at 4 p.m. I'm David Day.
And on Tuesdays at 4 p.m., I'm Hong Jiang.
Aloha.
Aloha.
Okay, welcome back. We're live here at Hawaii, the state of clean energy, broadcasting from the core of downtown here in Pioneer Plaza. And we have today in our discussion of waves of energy at HNEI, we have Luis Vega and Patrick Cross, both from HNEI, both project managers and energy specialists there. And we also, you know, if you didn't know, we have a viewing gallery, a spectator gallery. In the gallery, you can't see it, but take my word. In the gallery is actually my co-host, Ray Starling, at a microphone. Say hello so people can believe me when I tell them this, Ray.
Hello, Jay.
Thank you. See?
Can you hear me?
See, I told you. And Ray is listening and watching and will give us his famous summary at the end of our discussion. Okay, so here I am, and I find it. I find the right alloy. I say, Eureka!
No,
You
but
know?
that's really, you know, OTEC and wave energy, it is a system. It is, think about an automobile, you have many components. So this is just one of the many components, what we call the heat exchanger.
Yeah.
But perhaps more important, given the time limitation, is to talk about what we have been doing at the University of Hawaii, at HNEI specifically with our faculty, our associated faculty, is because we don't have the funding to proceed beyond the experimental plant and build what we call a pilot plant. We need millions of dollars to do that. We've been doing a lot of, we have some real sophisticated numerical models of the ocean now. And we have been exercising that model to ask ourselves, what would happen if by some sort of magic I will be able to deploy OTEC plants all over the oceans with the resources available? And how much will I extract before I begin to change the oceans, basically? And when we
What do
do
you mean have an effect on the ocean?
Right. When we do that, and this is theoretical, of course, so I asked one of the members of the faculty, really ingenious numerical modeler, an oceanographer, an engineer. I asked him, I said, okay, I want you to look at what we call the OTEC region, roughly speaking, between 20 degrees north and 20 degrees south. Roughly, that's not correct, but
Okay,
just
where
roughly
there are
speaking.
great disparities in
Right,
temperature. That's the region you're
right.
talking about.
Pretty much, yeah. And it depends on the ocean circulation too. And so essentially, we divide the ocean, let me use miles because we're in the U.S., into 15 miles, 15 miles or 15 miles, and we put an OTEC plant on each one of those squares. So we populated the ocean automatically with OTEC plants.
Yeah.
To see if we began to see changes.
Yeah.
And by the time we get to the point in which we're producing about 80% of the total energy consumed on planet Earth,
Yes.
we begin to see changes.
What kinds of changes?
The temperature will change, for example. In some areas, we'll get warmer, some will
Because
get colder.
you're taking the cold water
Right.
and you're bringing it to the
Right.
surface and so forth.
So we're asking ourselves,
So that's
what
not
is
a good thing.
Well,
to have
depends,
these
depends,
changes.
because first of all, there's no way I'm going to be able to deploy 250,000 plants like that. You know, it would be one at a time, right?
Yeah,
So
yeah.
this is a theoretical analysis using numerical models that are validated. So we're saying it is an ample resource. So with that information, you go and tell the United States, we're part of the United States, of course, look at this resource. And then the U.S. will come back to us, hey, but you're only one state out of 50. What happens to the other 49? That's when we begin to tell them, yeah, but the other 49 don't have the resource, but they can produce the turbines, the heat exchangers, the cold water pipes, the ships, whatever. They can do those things. By ships, I mean the platforms.
Yeah.
So we try to talk them into doing that, and that is a hard sell so far. So what has happened is, because we at HNEI have a good reputation where we're known throughout the world as quote-unquote expert for ocean thermal energy, in the last few months we were invited to give a talk in Japan and one in South Korea. And what is almost sad to see is that both Japan and South Korea are really moving ahead with OTEC to develop OTEC, and you will ask yourself, why are they doing that? They don't have the resource because they want to sell the equipment. The same way they sell your televisions and your cell phone and what have you, and Kia now the cars, the automobiles from Korea,
Smart.
for example. Oh, extremely smart. I was just a couple of weeks ago in a plant in South Korea, an OTEC plant, pretty much like what we had on the Big Island. And they can only operate 3 months out of the year because they don't have enough of a thermal resource the other 9 months. But they're experimenting with different components and trying to come up with the right control parameters, and they're going to go ahead and implement
Getting
OTEC.
patents on this. Does
The same with-
anybody, I mean, do you
the same with
have
Japan.
patents now?
No, it's really hard to get a patent because the technology has been available for a long time. I mean, the concept, sorry.
Yeah.
Some people might try to get a patent in how they weld this together and how, but that's small stuff.
Yeah, okay, but
I
so.
like
so
to look at the system.
Right. So that's really interesting that people who don't have the disparity in,
But they see a business.
temperature.
They see a business.
Yeah, it's business.
Yeah.
Yeah.
And they're getting a lot of support from the government.
Do they have a working model? Do they have
Oh no! At Saga University in Japan,
Yeah.
They have developed. They also been working on tech for a long time, and they
Yeah.
just installed let me use the word 50 kilowatt plant,
50.
Kumejim in Okinawa. That also works like that one works like maybe 8 months out of the year, and then
Because the temperature is
right,
not.
it's better than but the one in Korea only works like 3 months out of the year,
Yeah.
but enough for them to learn about it
Yeah.
and be able to experiment. The one in Korea is 20 kilowatt.
Are they using your technology essentially?
Well, not mine. I mean, ours, whatever.
Okay.
Yeah.
Ours.
Yeah, you can go back 100 years if you want to.
Okay. Okay. All right. So yeah, my question ultimately is, if we can, perfect this equipment, if we get it together with the right alloys and
No, but please don't
Changers and
get,
systems.
don't get stuck with the alloy because that's just one
it's only
part.
one element.
Yeah.
Okay, but everything.
Yeah.
Let's assume we can make everything work. How will it change energy? Because
God,
right now, I would venture to say there's no OTEC commercially
No,
anywhere.
none. You're right.
None.
Just imagine for a second that by magic we could have OTEC implemented in our state. And imagine that we can develop electric cars, for example. We can produce all the electricity we need for our houses and for our small industry that we have, and for everything basically. And if we have electric cars, we can even take care of the land transportation in Oahu, for example.
I know your secret. Your secret is you're going to bring it up from the depths. You're going to make it into hydrogen.
No. I'm not going to do that.
What's the
because
product of the OTEC machine?
Electricity.
Okay, but then how are you going to get that around? You're at sea with this.
It's called a submarine power cable. Keep in
Okay.
mind that right now in Europe, as we speak, they're deploying what we call offshore wind.
Yeah.
That is 200 to 300 kilometers offshore.
So
So they have
cable.
developed the cables. yeah.
Cable about
Yeah,
the
they-
size
they-
of a hockey
yeah.
puck.
And that's part of the cost. We know about how much it costs
Yeah,
and how to
yeah.
deploy. We know how to do those things.
You mean they have undersea cables in the world today?
Oh God, yes.
I'm only joking.
Sorry.
From Hawaii, you'd think it never happened before, and it's like a mystery thing that comes down from heaven. But in fact, it's all over the world, undersea cables.
But we try to somehow liberate ourselves from dependency of petroleum fuels. We need to use all the resources that we have. So in addition to ocean thermal, we also have, of course, the wave resource. That maybe Pat can talk a little bit about that right now.
Okay, before we get on to that, though, I'd just like to know your expectation here. By my recollection, this is the year 2014, and we've been talking about ocean thermal energy for 30 years.
Yeah, exactly. Yes.
And we got a lot of people, who swear by it but can't raise the money to actually make it happen.
Right.
So right now, there's a long continuum of talk, but no actual OTEC.
No, I tell you.
And so when is this going to happen,
Well, I
Luis?
can tell you-
And we speak to that camera
Okay,
and tell
sorry.
them your best knowledge.
No,
When is it going to happen?
What I can tell you definitely is that it is not going to happen in our country. It's going to happen elsewhere first. There are two real serious companies working in the Caribbean to implement OTEC there. And then we have the Japanese and the Koreans working to develop the technology to implement it who knows where, but they're going to do that. So I think the lead is going to be we're going to be led by other people, and then I hope we wake up to that. The French are really active in Martinique. The rumor is that they have gotten funding from the EU to implement a 10 megawatt.
Well, that's major.
Yeah, that would be the amount of energy you need for Molokai, for example.
Yeah.
So that's a major development, and they have gotten. I understand that they will make the announcement pretty soon.
So with
For
all of
example.
this, where does Hawaii fit? Where does HNEI fit? Are you at the front end of this? Are you going to be part of the bonanza when it happens?
We surely hope so, because we have the know-how really at HNEI. But we got 3 or 4 people that have worked in OTEC for a long time that happen to be housed at HNEI now. So we have the know-how about the resource and the operations and maintenance. We have a lot of information at HNEI.
What about the United States federal government? Are they putting meaningful resources into this project?
Well, in simple terms, they put a lot of resources in the 80s and even through the early 90s. But now we got to the point in which we know that the next step requires $200, $300, $400 million over 5 years, and we don't have that kind of money. So the U.S. just cannot go in that direction. Our federal government, through the Department of Energy, is sponsoring other forms of ocean energy, specifically tidal energy and wave energy. So we are doing some of the wave energy here in Hawaii with federal funding.
Okay, if we had this technology, my last question, then we'll take a break. If we had this technology, I mean, we the world had this technology, would it, and I know from that model you talked about that we wouldn't want to overuse it, but would it be a significant contribution to the world's renewable energy to have that?
Oh God, theoretically, like I said, based on the numerical model, of course, to be, assuming that I can somehow install 250,000 plants, 100 megawatt each throughout the world, we can produce 80% of all the energy.
All the world's requirement.
But that's theoretical, of course, and we have to do it one step at a time.
Okay. All right. I mean, I'm still digesting that, and while I'm digesting it, let's take a short break.
Sure.
Okay, that's Luis Vega and Patrick Cross. Patrick is going to tell us about wave energy right after this break. Here on Hawaii, the State of Clean Energy, where we're talking about waves of energy at HNEI. We'll be right back.
Aloha, my name is Willow Chang Alion, and I host a show called The Art of Life. We air live every Friday from 2 to 3 p.m. And what we do is basically we focus on individuals who create a unique sense of place for Hawaii. These are movers and shakers, artists, innovators. They are also traditionalists. They're all involved in the archival process, and they make this place a unique place, one that makes Hawaii a richer place to be. I hope you do join us, and certainly tell your friends about the show, whether they live here or they live abroad. It's a way to give back to our community. We're keeping it Pono.
Okay, we're back. We're live. We're Hawaii, the State of Clean Energy, every Wednesday, 4 to 5 here on ThinkTech. And we're talking with Luis Vega and Patrick Cross from HNEI about waves of energy at HNEI. And the reason we want to talk to them now and later and always keep on talking to them is because we believe that all renewables, should be employed to help us in our energy issues. It's not just PV. You can quote me on that. And it's not just wind either. We need to look everywhere and have a combination of renewable sources, and these are important renewable sources. And at the end of the day, they could be critical, to renewable energy in Hawaii and elsewhere. So turning to you, Patrick, what's going on with wave energy? Let me just say, I remember that at the Marine base in Kaneohe, they had these buoys that rose up and down on chains. And they had some sort of flywheel arrangement inside, and they generated electricity, and then they fed that back on a submarine cable, and there were a number of them. And then, what? One of them?
Yeah.
Okay, well, it seemed like a lot. When you don't have anything else, it seems like a lot. And that was exciting. It was in the paper, and then it stopped being in the paper. Colonel Rice was there.
Oh, great man.
Great man. And he retired. He went to some landlocked state for his retirement and did not pursue it. It was a shame. It was a great loss. He was a fantastic man. A king of renewable energy he was. I don't know what happened to it, so bring us current.
Okay, bring you current. So yeah, HNEI was not directly involved in that effort. That was an effort between the company that was testing their device, called OPT, and the Navy. So basically the infrastructure there at the Marine Corps base, which is the same infrastructure that we will be using going forward, and also adding to, the Navy is actually adding additional infrastructure. So that was a test that kind of got all the data out of it that it could, and after a period of time they recovered their device, and we've sat quiet since. But there's now new Department of Energy and soon to be U.S. Navy money to resume that effort with new developers, new companies that are developing wave energy conversion devices. And so we're excited by the fact that as soon as early this fall, we'll have another device deployed at the Kaneohe.
Tell us how it works. I mean, can you give us a word picture of exactly how this thing works?
Well, so over the course of the next few years, we're going to see a number of different devices. And when I say different, I mean radically different. We're not talking about 3 blades versus 4 blades or something on a wind turbine. We're talking about devices that don't look really anything like the next one. This first one will be a small version of what's called a point absorber, so which is basically what was there before, the OPT device, which basically rides up and down on the waves and uses a number of different methods to convert the motion into electricity. So this one will do that as well. It's 2 vertical spars with a float in between that will rock back and forth and generate the power. But then we're
What's the material?
it's all steel. It's just a big heavy. We can get into why wave energy, like OTEC, is hard.
Corrosion. It's the old corrosion story.
The ocean is not a friendly environment to do anything in, and there's no exception with wave energy. So these are large devices necessarily in order to generate the kind of power that makes them cost effective. And it's a corrosive environment, so it's a real challenge, and it requires substantial investment, and it requires what we're excited about is that we get to step in and help the Navy to operate a test site where, I mean, the developers, it's cost prohibitive to go out and test their concepts that they can draw up on their computers and build small prototypes and test in wave tanks, but to actually get data at sea and test out their concept is very expensive. It requires ships to pull things out to sea, and then requires the capability to maintain a device once it's in the ocean and getting bounced around and probably breaking and having to be re-engineered and all of it. So,
What about, the graduate, where he turned to his future son-in-law and he said, remember this? You can find this on the web anyway.
Plastics?
Yeah. Oh, you knew what I was going to say.
It's one of my favorite lines.
What about that, Patrick? Why not plastics? I mean, plastics do not corrode, right?
you know, we may see it. I don't know. The early devices that we've been exposed to are not, to my knowledge, taking advantage of.
Louise, do you know something about this?
No,
I mean,
yes,
it's too quick about that line.
No. Sorry. I'm still looking for Mrs. Robinson.
You're not the only one.
God, that was bad. Can you delete that?
And Bancroft it was. I'll just have to mention that.
No, of course, like fiber reinforced plastic FRP will be used. It's just that for these experimental devices, it's just simpler to do it this way at this point. Because you're most interested in how the device moves up and down, and that doesn't matter what material it is. And then the inner guts, what we call the power takeoff, is what really matters. So they're testing that basically. Mm-hmm. How do you convert the motion to something that will generate electricity?
Mm-hmm. Okay, so what's happening in HNEI right now? I mean, where are you on this? Are you doing the guts? Are you doing material science? Are you doing combination? Who are you working with exactly? Tell us.
Well, I should turn it back to Luis really to talk about what we've been doing for the last 3 years, basically, which is to facilitate the environmental assessment to allow the Navy to build out this site and begin to bring the companies in for testing. That has been a lengthy process. He had jet black hair when he began it, but it's been a difficult effort with the Navy and with NOAA and with technical input from
just to test
HNEI, just to get the site infrastructure created. But the good news is that is finally completed
where is the site?
now. It's Kaneohe,
same place.
right off the end of the runway at Kaneohe Marine Base.
See, if I might add, our role, this has to be clarified, is that we look at these devices that will convert the wave energy into a useful form. To us, they're like, let me use the word, a black box. Mm-hmm. So what we do as HNEI is we measure the input. The input in this case is the wave, so we measure the waves, and then we measure what comes out of it. We don't get inside the device. I mean, we know because we're engineers, but we don't, that is proprietary. That belongs to the developers.
And
But-
it's probably patented.
Yes, yes. But the thing that's really important, that's beautiful, really, is that thanks to the U.S. Navy, they're going to have what we call 3 birds. Meaning they're going to be people testing at 30-meter depth, 60-meter depth, and 80-meter depth. The one that you mentioned before was at the 30-meter depth, and the power cable was left behind. So we're going to use it. Now we're adding, we meaning the Navy is adding 2 more, all the way to 60 meters and to 80 meters. So we're gonna have 3 separate companies testing there, and we're gonna be the, let me use the word, the third party analyzing their output, but not getting inside their how they do it. That is up to them.
Well,
But the beauty that is really important to emphasize is that what the Navy has done that is really beautiful is that these submarine power cables now are hooked such that once you make electricity, it will be transmitted to the distribution grid inside the Marine Corps base and measure. So you have to, of course, get a permit to do things right, use the right equipment with our power company. But the people that come and test here are going to produce electricity that is HECO quality electricity that HECO can take and use and purchase one day.
That's the black box,
Oh,
though.
Yeah, but no, the beauty is that we're what we call, we're tied to the distribution line. Because a lot of people have tested in the middle of the ocean, but not tied to the utility
Yeah.
and distributed the energy they produce. So that's a real beautiful situation for us
Yeah.
to be able to have that taking place here in Hawaii.
Right, so we know exactly what happens. So, but you know, this all suggests that there's different processes, different wave actions at different depths. And do we know what depths are the best? I mean, if you're testing at 3 depths, then that suggests you don't know yet. Which depth is the optimal depth? And the other thing, you know, talk about firm power that you would deliver, say, to the Kaneohe Marine Station. Does it work 24/7, or do you need some intermediary battery device, a storage device, in order to give, you know, firm, uninterrupted power? I mean, do we know about this? Is this part of the system that's happening?
You want to take it? I can take it.
You can expound, but actually that's a potential and likely future area of investigation is looking at how to integrate the wave power into the grid. We're focused initially much more on just getting the first few devices deployed and beginning to create power in the first place. But we will, I say we, it's the Navy's side. I have to keep emphasizing that. We're sort of the third party, as Luis mentioned,
So,
we've got a lot to do.
I'm just trying to envision this, and I see the thing related to the swells in the ocean, the moves of the water, you know, up and down and around. And if there was a big swell or a big move in the currents, whatever, that would create a lot of energy. And then if it got quiet a little bit, then it would be less.
It's like it's like other renewables in that it's going to be variable. With wind and solar, obviously, we have spiky generation, and the same will be true with waves. But in all likelihood, to a lesser extent, it's more predictable, but it will still be spiky. So there will be some degree of smoothing required.
So that's another level of technology.
It is what we call an intermittent resource, and of course the frequency of the waves is different than the one of the wind, different than you mentioned photovoltaics a couple types of PV, and that of course depends on the cloud coverage and so on and so forth. So,
sure.
but imagine a day when our state will have wind over here, PV over there, and waves over here, and then we'll be easier to integrate it because the waves might be producing the wave energy conversion device might be working beautiful at midnight, where your PV doesn't work at midnight. But they're all intermittent, yes, and that's why also at our institute we're doing a lot of work in integrating different types of energy into the grid. And how do you do that? What we call smart grid nowadays.
Yeah.
And if I might put 2 bits here for OTEC, the beauty of OTEC is what we call base load. OTEC works 24/7.
OTEC is
Yeah.
firm.
No, it's not firm. It's 24/7 because OTEC is highly dependent on the temperature, and as you know, the temperature varies.
Changes.
But
Okay.
there's always enough to make some.
So it's more firm.
Yeah.
Yeah. Well, yeah, this really, can I take off a little bit about what you said about HNEI's work on trying to integrate renewables that all have variables in them, and they do. I mean, it's the nature of the planet. Everything changes. So smart grid and smoothing the curve. This is critical. ultimately. in
Well, there's some
renewables.
amazing work going on at HNEI right now.
Can you talk about it?
Uh,
Or,
you
or,
know,
or would you have to, hurt me?
I would prefer you do it with the people that are working on it. I mean, I know a bit about it.
Well,
but
just in general, the nature of the solution. What solutions you working on?
Well, for example, I have done work in what is called rural electrification, where you charge the battery all day long when the sun is shining, because you come home at nights from the farm and you discharge the battery to turn on your lights or maybe your radio or whatever. But in this case, the idea is to, like it's being done right now for some wind farms, you put enough battery there not to store energy for hours, but for minutes, so you can smooth the output. So it's a smoothing idea instead of storage, basically.
Yeah, short term.
Right, and that way, because it's integrated now with the whole grid, then you know how to manage the grid, basically.
I mentioned before, I was not joking actually, that maybe you create with this electricity, which may be very variable, hydrogen, and then you use the hydrogen as a medium. And if you burn the hydrogen off in a fuel cell or otherwise, that's going to be just as firm as you possibly want.
That, to me, in that regard, you're talking about hydrogen as a way to store energy storage.
Yeah.
But you can also do energy storage in a battery. So they're kind of,
You
the
can
way you
pump
describe
it in
it,
various,
yeah,
okay, got
the
it.
way you describe it is like you can use, then you have to do a cost analysis and so on and so forth.
Exciting work.
Yeah.
Yeah.
It is. It really is. And the thing is that we have to think about it, because it's what are we. One thing I like to tell people is you get the best possible optimistic estimates of how much we have worldwide fossil fuel like. And the best estimates show you that the amount of fossil fuel you have, petroleum fuels, for example, at current day uses throughout the planet Earth, we have 50 years left. And that's assuming that nobody grows like China is growing or Brazil is growing or what have you. And when you look at coal, you have like 100 years left. Natural gas, 120 years left. And that is really around the corner when you think about it. When you think about your own lifetime, now you're 80 years old, you can see that, I just called you 80 years. You didn't
Oh,
really
no. It's coming soon. What about gas?
Yeah.
Doesn't gas change? There's all these discoveries around the world in gas.
Yeah, but the thing to me is that, we have this planet with so many resources, and we pretty much know what they are. So maybe you find a way to tap them over here, but maybe the ones here are being depleted. So globally, it's a global market, really. Like we're producing now more than we consume, apparently, with fracking, but that's being sold on the open market.
Yeah. Well, which one would you take? I mean, our
All of the
title
above.
is Waves.
All of the above.
I knew you were going to say that. But if I forced you to make a choice between wave energy, a la Cynthia Thielen in the state legislature, she has ideas about that, and OTEC, and they both have similar issues, and they're both on different timelines. Which one would you pick to put, say, $500 million into? Which one?
You're. I mean,
I'm making it hard.
Yeah, but it's a good question, and it's real simple. You look at the resource, you look at the characteristics of the resource. You have to say OTEC. There's just no two ways about it. I wouldn't see that in California because they don't have ocean thermal energy, but. No, but we need them all, really. I really sincerely believe that. We need them all. It's like at the individual level, what you do in your own house. Well, first you have to conserve, right? You get your solar water heater, you get your compact fluorescents, you hang your clothes on the carport, and you begin to conserve as much as possible. And then maybe, thanks to the beautiful credits we have now from the feds and the state, you put a PV panels in your house. You do those things, right? And then what do you do next? Maybe get an electric car. You keep on moving like that, one step at a time. But you need them all, really.
Sure, a full market, a market of all choices. Well, I think it's that time in our show where we ask our studio audience, in this case, namely Ray Starling, who's actually co-host on this show, and to summarize and maybe point out what he's learned and how this all affects us. Ray, what do you think?
Well, I want to thank Louis and Patrick for coming today. We have not had these kinds of technologies discussed a whole lot on the show. And it's very interesting to hear, especially the thoughts about the fact that these technologies are viable, but they won't make it to commercial use until some entity, probably the government, puts a lot of money into it because the people who normally invest in fossil fuel plants, they don't put their money in something that has never been done before, and so it had never been done on a commercial scale. But once you do that, if we can get the government funding, it sounds like both of these technologies are likely to be a contributor to getting away from the carbon fuels. And so I really appreciate your being here. And Louis, I appreciate you also gave us another negawatt moment right there in the last couple of minutes.
I heard that too, yeah.
Yes, we're going to have you back to do the negawatt moment for us in the future. Or we'll see. You won't need anybody from Hawaii Energy. Louis can just do the negawatt moment and then roll right into what's happening with OTAC. But yeah, this was very good. I really appreciate it. And there's a lot more to the story from what I know that I'd love to hear more about, and perhaps we can bring these gentlemen back again in the near future to talk about some of the more technical parts of what they're doing. I mean, that is of interest to a lot of people that are just trying to figure out how this all works.
Yeah, we need to have you back. We need to educate people about exactly what it is and how it works and what you need to solve before it can, become deployable. Anyway, thank you very much, gentlemen.
Thanks to you, Jay.
Luis Vega and Patrick Cross, both from HNEI, project managers and energy specialists there doing research in these areas. Here in Hawaii, the state of clean energy. And we've been talking about waves of energy at HNEI, and it's been very interesting to catch up with you. Thank you so much.
Thank you, Jay.
Thank you.
Aloha.